Okay, in this video, we're going to solve some of our more basic exponential function word problems. And for all of these word problems, we're going to use our exponential equation, y equals a times b to the x power. And our concept's been working on about initial values and growth and decay rates. So let's look at our first question here. $9,000 is placed to an account with an annual interest rate of 7.75%. How much will be in the account? I got a typo there. So account after 18 years to the nearest cent. All right, well, this is an exponential problem. Y equals a times b to the x. A is going to be the initial amount. How much money did we put into the account? We put $9,000 in the account. So A is going to be $9,000. Now you ask yourself, is this going to be growth or decay? Well, if I'm placing my money into an account that has an interest rate of 7.75%, this is going to be growth. So growth means that B is going to be equal to 1 plus R. Well, we got to figure out what R is. R is our rate. So if R equals 7.75%, I convert that into a decimal, which means I need to move the decimal place twice to the left. So R would be 0.075, and which means that B is going to be equal to 1 plus 0.075, which means B is 1.075. So I got B, I got A. I write my equation, which would be y equals 9,000 times 1.075 to the x power. Now, using this equation, we're going to figure out how much money do we have to the nearest cent after 18 years. So I'm going to put 18 where the x is. And so we'd have y equals 9,000 times 1.075 to the 18th power. Now, to get this value, you will go to your calculator and you will round to the nearest hundredth, the nearest cent. And so we end up with $33,082.24 after rounding appropriately. Okay, another example here. So a car is purchased for $20,800. The value of the car depreciates at a rate of 10.75% per year. What will the value of the car be to the nearest cent after 13 years? Well, this is going to be an exponential problem. Y equals a times b to the x power. The word depreciates means that it's going to be decay. Now, but I got a little ahead of myself there. I need to find the initial value, A. The initial value is going to be what the person paid for the car. So $20,800. Now, since it uses the word depreciates, this means this is going to be a decay function. Our value is going to be getting smaller over time. And decay means that B is going to equal 1 minus R. Well, R is going to be the rate in which we depreciate at, so 10.75%. I convert that into a decimal, so I move my decimal 2 places back to the left. So R is going to equal 0.1075. And we go put that into our B line. So B is equal to 1 minus 0.1075. And that's going to tell us what B is. And we get B is equal to 0.8925. And so we write our exponential equation, which would be y equals 20,800 times 0.8925 to the x power. So that equation will tell us how much the car is worth. We want to know how much is the car worth after 13 years. So we're going to put 13 in where the t is. And after we do that, we'll go to our calculator and we'll see what the value of the car is after 13 years. And so after 13 years, that car is only worth $4,742.10. Okay, let's look at another one here. So the town has a population of 17,000 people. It grows at 4% every year. So my indication when I see rates, we need to be thinking exponential function. Y equals a times b to the x power. The population they give me of 17,000, that is going to be my A. It grows at a rate of 4% every year. So what that means is we know that it grows, it's going to be growth, which means that B is equal to 1 plus R. R is that percent that they give us. So R is equal to 4%. I got to convert that into a decimal. So I move the decimal twice to the left. So that'd be 0.04. So B would equal 1 plus 0.04, or 1.04. So we plug all of this back into our equation. We put the 17,000 for A, and then we write times 1.04 for the B, and then we put X as its exponent. We want to know what would the population be after 5 years. So I put 5 where the X is. And then you go to your calculator and you go see what that equals. Okay, and they told us to round to the nearest whole number. So after 5 years, our population is now approximately 20,683. All right, last one of these problems here. We have an element with a mass of 500 grams. Key word here is decays, and they give me my percent of 26.3% per minute. And so we have the key phrase of decaying and the rate. So y equals a times b to the x is the equation we're going to be plugging stuff in. A is how much we start with, so 510 grams. They even use the decay word for me. So this is exponential decay, which means, so B is equal to 1 minus R. Now R is that percent that they give me, 26.3%. I convert that into a decimal, so I move that decimal twice to the left. So R would be 0.263. And so I'm going to figure out what B is. So B is 1 minus 0.263. So B winds up being 0.737. So I have B, I have A. I can put this into my y equals equation here. I get 510 times 0.737 raised to the x power. Now we want to figure out what is that value after 7 minutes. So I'm going to put in 7 for the x and see what we get. So we have 510 times 0.737 raised to the 7th power. And we go to our calculator and see what that equals. And they want us to round to the nearest tenth of a gram, so that's the first decimal place, and we wind up with 60.2.